Alright, so, don't twitch.
Okay.
Alright, now, so I added H2. It is now not balanced. It's not at equilibrium anymore. It's like this. So what direction, someone raise your hand and tell me, how does it have to shift to go back to being balanced? Someone besides Amik. How about Corey? How does it have to shift its weight to go back to being balanced?
It has to make more products. It has to shift that way.
Right, it shifts towards the products or shifts to the right. So if I take some of the reactants and put it over here on the product side, it will now become balanced again. Balance means equilibrium. So the answer to number 2, under equilibrium shift, you should have to the right. Now, you saw me take something from here and put it over here. So, how does that affect the N2 that was here? If I'm taking the reactants and making products, what happens to the concentration of the N2? Decrease. Good. So this side decreases in concentration because I slid it over here. What happens to NH3? It increases. There's more particles over here now. So for number 2, you should have the right, decrease, increase. For number 2. All right. Let me start over again. Oh wait. There. Okay. So number 3. Let's add some NH3 to this now. So now I'm going to add one of these to this side. I'm adding NH3, so now we're like this. Which way does it shift? What do you think, Caitlin?
Left.
How does it shift to go back to being balanced? It's going to have to shift some of the weight from here.
You remember how yesterday I just, like, I understood it, but I worded it wrong?
Yep.
I forgot what I said, but, like,
I don't remember.
like, I understand that when you add more to one side, it's going to shift to the other.
Yes, it's going to shift to the other. Good. Yep, that's good enough to remember.
Okay.
That's good enough. So it's going to shift some of the weight over here, and it'll go back to being balanced. So we shift to the left towards reactants for number 3. Therefore, we're making more reactants. So N2 increases and H2 increases. If we're going to shift this way, we're making more N2, more H2 on the reactant side. Okay? So for 3, you should have left, increase, increase. Questions? I realized I wanted you guys to commiserate. So let's do that for 4, 5, and 6. So, Corey, you two talk together. Used to. Used to. Used to.
What's going on now?
You guys and you guys. So Eden, talk to Amik. Share your answers, 4, 5, and 6. Talk to each other.
No, I mean.
Knock it over, I'll make fun of you every day.
Are we going over both sides?
Yeah, go ahead and do the other side too.
Wait, okay, so you have this thing, right? And then you take N2, so that until 4, so you need to, yeah,
Okay, goodbye.
I was thinking everyone knows.
Do the other side too.
Knock the iPad over.
So like you take away,
You gotta do the other side, Amik.
take away NH3, so then,
Oh, wait, do you
take away
have
NH3.
I have right.
Yeah, but I'm thinking, take away NH3, but then if you take away NH3, then it wouldn't be H one equals that side, so you have to take away H.
I love how everything is replaced by active.
4, I have left, increase, decrease.
Because then you have to balance it.
Okay, for 5, I have left, increase, decrease.
And then number 5,
I have
left,
right, decrease, decrease.
6.
Okay, number 1, I have
Right,
right,
decrease.
increase, increase. For 2, I have left, increase, decrease. For 3, I have left, increase, decrease.
Yeah. Is this going to be a couple
For 4, I have right, decrease. Why is it getting mad?
Well,
I'm having some toy.
Nothing. So knock the iPad over.
Well, yeah, I didn't know that video was like this.
Go ahead and run that.
Earthquake. There's an earthquake.
Right remains the
Don't
same.
trip. There's an earthquake. Up, it's rattling.
Say hi.
3 left increases.
Say it. Hi, iPad.
Put bunny ears on Mr. McCoy. Oh, I didn't say anything.
Don't say hi to the iPad.
I know.
Oh, is it still on?
Hey, where's your buddy anyway? Press.
Oh, he's on vacation.
I know, where?
South Carolina.
You told me, but I forgot.
Till next Monday. Yeah, he didn't tell me till he left. That changed. What?
Love juice with the best.
Guys are bad with stuff like that.
Country store.
Alright, here we go. Back to reality. Alright, so, now, I'm going to show you with the balancing beam board here how to do number 4, and then we're going to try and do the rest out loud. If you want me to show you how to do it with this, please let me know. It's okay. I go kind of slow with this because after we go over this homework, the rest of the time we're doing equilibrium things, I go a little faster because I feel like you spend a lot of time on it. So it's okay to go slow at first. Here we go. Remove N2. So where's my N2? So if I take this off, okay, I don't know if that's going to work, but if I take that off, so that's number 4, now what? Which way does it have to shift? Tara says this way. Very good. That's why I screwed that up. So if I take some of this and put it over here, it will be balanced, but if I literally put it on there, it won't. So let's assume I put it over there. It's just the weights don't always work out unless I think about it. So yeah, we shift some from the products to the reactants. So we're making more reactants. We're using up our products. So therefore, for 4, it would be shift left, increase for H2, and decrease for NH3. Questions on that? Okay, 5. I'm going to do these two out loud here. Stop me if you need to. 5, we're shifting left, N2 increase, NH3 decrease. 6, we're shifting right, and then decrease, decrease. Okay, flip it. Okay, here we go. I'm going to do all these out loud. Number 2, we're adding I2, so we're shifting right. And then we're decreasing H2, increasing HI. Number 3, we are shifting left. Increase H2, increase I2. Number 4, we're shifting left. Increase I2, decrease HI. Number 5, we're shifting left. Increase H2, decrease HI. And then number 6, we're shifting right, and it's going to be decrease, decrease. Questions on any of those? All right, take out your notes. I'm going to replay the video about pressure. I'm going to replay that video showing the pressure change, and then we'll do some practice problems. And before you put your homework away, or if you did, take it back out real fast. On this side, do tomorrow, do number 8 and 9. So the increase and decrease pressure, that would be 9 and 10. 9 and 10, sorry. Number 9 and 10 on this side. And then the side with the 2 charts, do 9 and 10 on top. Bless you. 9 and 10 on the top one, and 7, 8 on the bottom one. That's all you have to do for tomorrow, besides the journal and reference tables. I mean, reference tables.
What?
Review book. Huh?
How many on this side?
Number 9 and 10. Do number 9 and 10. And then don't forget journals and review book, chapter 4, and we got that quiz now. All right.
It's like Friday.
Ooh, close. All right, lights, please. Can you guys, Dan, while you're up, help him? Here we go.
Wait.
Notes should be out.
9, 10, and 7, 8.
Yeah, 9, 10 on the side with one chart, 9, 10 on the top chart, and then 7, 8 on the bottom. Yes, yes?
Yeah. I won't be here Monday either.
What?
Yeah. I'm not going anywhere today. I have to go look at a stupid college.
Corey, how close was that?
Where are you going?
SUNY Adirondack.
SUNY where?
Adirondack.
Adirondack?
Adirondack. Yeah.
Okay. Well,
Oh my gosh, that scared me.
oh my gosh, I'll pay for it.
That is so funny. That is literally, oh, it's too good.
Dang it.
No. Oh my gosh, how painful. Shut up.
Mr. McCoy,
Oh my gosh, oh my gosh,
Yeah.
oh my gosh.
you should turn around and break the fourth wall
Oh my gosh.
in your own video.
Oh my gosh.
Talk directly to the audience. Viewing in YouTube.
Sorry. Changes in pressure. Here we go.
Why are we already halfway through the video?
because I don't want to show you the concentration. We just spent a whole 20 minutes doing that. So changes in pressure is what we're going to talk about today. And then Monday, or tomorrow after the quiz, we'll talk about temperature, and then finish everything up on Monday with this stuff. So it's unfortunate you're missing both days. Here we go.
The stress to a system at equilibrium is only applicable to gaseous systems. For this stress, we will examine another hypothetical reaction
Try and pay
at
attention.
equilibrium, where reactant A reacts with 2 moles of reactant B to form product C and product D. An increase in pressure means that there is a decrease in volume, so there is less space. Equilibrium will shift to the side of the reaction with fewer moles. In our example, an increase in pressure will cause equilibrium to shift to the right, since there are fewer moles. 2 moles compared to 3 moles on the left. A decrease in pressure means that there is an increase in volume, so there is more space. Equilibrium shifts to the side with more moles. So in our example, equilibrium shifts to the left.
Okay, and that's it. I'm going to explain this again though. So if you think of gas particles actually existing, you can visualize them being a certain distance apart. Before any pressure change, let's say the particles are this far apart. If we increase the pressure, what's going to happen to my hands? Move closer together. So if you increase the pressure, they move closer together. They don't want to be closer. They want to be this far apart again. That's where they were before the pressure change. So really try and follow me here. Caitlin, you with me?
Yeah, I took notes in the video and I missed something.
That's all right. Forget that for now. Just listen to what I'm saying. So they want to be this far apart. When you increase pressure, they get pushed close. So where is there more space? There's more space where there's a lower number of moles. I chopped it off, but there's 2 moles here. So when you increase the pressure on gases, they always shift towards the lower number of moles. Why? There's more space. What does that do? It allows them to expand, so they can go back to the way they were. And then the opposite is true. If you have gas particles this far apart and you release pressure, they expand. They don't want to be expanded, they want to be here again. So if they're expanded, they shift this way, in this example, towards the greater number of moles. Why? There's less space. There's more particles. So if they got expanded, they can shift towards where it's crowded, and now they're going to be forced to be closer together again, and that's good. That's what they want. So when you decrease pressure, it goes towards low moles. Increase pressure, it goes towards the higher number of moles. That's the best I can do. I think the video is pretty clear. It's a good animation as far as using my hands and explaining. I hope that helps a little bit. So I'm going to kill the video. We're going to take that concept and we're going to do a few, or at least 2
video. What does the video do to you?
Alright, I'm going to turn it off. Alright, so let's do a couple practice problems and see how we do. Lights please. Get those again. And here we go. Write this reaction down please. N2 gas plus O2 gas in equilibrium with N2O4 gas. And let's go with 2 of those. Okay, so write that down, please. Thanks, Ryan. So given the following system at equilibrium, so write that down. Here's the question. If the pressure, I'm going to give you 2 questions. Give you 2 questions.
Why are you laughing?
Because my voice like squeaked or broke or whatever, you know, like pre-pubescent voice. Anyways, actually not pre, during puberty. I'm going to give you 2 questions. Just write them both down. You're going to try and figure them out. And then again, you're going to talk to your people around you and figure out the answer. And then I'll call on a pair and you can
I don't
explain
think any
it.
of my people were in here.
If the pressure on this reaction is increased, pressure on this reaction is increased, in what direction will the equilibrium shift? That's question number 1. Number 2, how will this affect the O2 gas, that's a G, concentration? When I put those brackets around the O2, it stands for the word concentration. So I could write out oxygen concentration or just put the brackets. Brackets means concentration. Now that's kind of weird. That's how it works. So go ahead, write that down. And then when I say talk or whatever, you can meet with your people and discuss the answers. So I'm going to walk around and see what you're writing first, then I'll have you discuss. I just don't like to see it out.
It is a good computer.
What? You awake now? Hurt my shoulder pushing. It's easier to pull than push.
Do you still like if you're just standing there, does your arms sort of like just crinkle up and go here again? Because of all that time sitting there.
I in the past have realized I've been walking like this. Talk to your people. Go ahead.
Have you done that? What'd you get for one?
Number 1.
Caitlin, after class, go see Miss Corso. She has your working thing.
I didn't know what's
Oh yeah.
Boom.
Oh yeah.
Who's Eden? Who are you sharing with? Destiny?
Yes.
Okay. Ryan, who are you talking to? Oh, compare with Corey.
Oh, that is.
Okay. So now you have to talk about why. That's why I have you do this.
I will argue the point. Can I argue the point with them?
Sure.
Yeah, but if it's
Ryan, I'll argue the point.
Yeah.
So if
That makes sense.
You missed the other day. I don't know what day.
that's
Right, Ben?
Oh,
Yeah. What? Tuesday? Monday? Wednesday?
Monday.
Oh wait, no, I got my sense of direction mixed up.
Okay. Well, the quiz tomorrow is on stuff I think you missed.
I was thinking
So,
right, but
I'm pretty sure I put it on my YouTube channel, Mr. McCoy, BKW
I just
Chemistry.
almost wrote right.
There's like 9 subscribers. I'm big time.
Impressive.
But anyways, you can check that out if you want, or just make sure you everything we went over before. How do you feel about that?
All this.
Not this stuff. The review for the quiz. The potential energy diagram. A little bump.
Oh, that, yeah, I'm talking.
Okay. Yes. Yes. Okay. Here we go. Number 1. We got to get another example done. So number 1. Which way does it shift? To the right, because there's lower number of moles.
I said left.
Wait, in the video it said increase in pressure means decrease in volume, and it means it has more space, so it shifts to the side of a lower number of moles.
Very good.
And that
But
has less
if I increase the pressure, there's like, look at the moles. There's 2 and then 4 on that side, and then there's 2 and 2.
Hold on. Hold
Oh
on.
my god, I didn't see the big 2.
So there's 3 moles here, 3 moles here, and only 1 mole here. Kaylin, you with me?
Yeah, I'm making them.
3 to 1. 3 to 1. So there's only 1 mole on the right and 3 on the left, so it shifts to the right, the lower number of moles.
Okay, so I had the right idea. I just
Yes.
don't-
You just made a mistake. Now, how will this affect O2? So, if I took all these weights and shifted it that way, what would happen over here? There'd be nothing there. So it decreases. It decreases because we're shifting away.
I did.
Let's do another one.
Can we use the same, like, is it going to be the
Yep,
same?
same reaction.
Oh, okay, cool.
Same reaction. Here we go. One more question. So, if the pressure is decreased, if the pressure is decreased on this reaction, if the pressure is decreased now, make sure you write the question down. If the pressure is decreased on this reaction, how will this affect the, I don't know, let's go with the N2 gas concentration. Okay, so some of you may pick it up quicker than others. Just keep it to yourself. I'll call on somebody. We're not gonna commiserate on this one. If the pressure is decreased on this reaction, how will this affect the N2 gas concentration? So first figure out how it shifts. Then think about how that affects the N2. That's how That's how we do this.
Like before it does what it wants to do, or after it does
After it does what it wants. After the shift, then think about what's happening then. Okay, catch it. I'm not asking for volume.
But you said how will this affect
The
it?
N2 concentration. N2 concentration. So do you know what that means? The amount of N2. What happens to the amount of N2?
Oh, okay. No, I thought it was like how close together.
Concentration is another way to explain how many particles there are. That's what concentration is. Alright, so here we go. If we decrease pressure, we shift towards the higher number of moles, which is to the left. So we're shifting this way. If we're shifting this way, we're taking all of this weight and sliding it over here. This side is going to increase in concentration. These two will increase, N2O4 will decrease in concentration. Your homework is practicing that. Amik, are you with me here?
Yes.
You sure?
Yes.
Okay. So, increase in concentration. Again, those, what do you got? 1, 2, 3, 4. You got 6 problems for homework. It's all on pressure. Just remember, increase in pressure, you go towards low moles. Decrease pressure, high moles. We're basically done. Have you guys ever been in a class in this school where you have those little handheld things where you type the answers in and the teacher gets it on their computer?
I've always wanted to do that.
We just
They have
No.
those here.
Yeah, there's only one set. I think it's in the elementary right now. It's been there most of the time. I really would like
try that.
to have video or smart whiteboards for each student so they could write on it and the answer would come up on my computer.
That sounds so cool.
Because a lot of kids don't like volunteering answers or don't want to be called on. And that's okay, but I still want to see how they're doing so I could see, and I can even have your name like next to it and say, okay, Dan always gets this one wrong, so I have to really focus on Dan with this. So, those exist. Those things exist. I would love to have them. Kids would like that, right? You guys would like that?
Yeah, that'd be really cool.
Don't worry, Destiny. There's always tomorrow.
Oh, wow! Oh,